Okay, first thing we're talking about today, we are going to discuss interval notation, order of operations, polynomials, and complex numbers. I'm going to do the first half of notes, give you a break, and then we'll finish notes. Sound good? Okay, first thing that we need to talk about is we are converting between what's called set builder notation. We're going to graph it, and then we're going to do interval notation. Set builder notation you may or may not have seen before. It looks pretty funky. I'm going to tell you what it means and then what you actually need to pay attention to. The way you read this part of set builder notation is officially that reads x such that. So that's what the bar means. The bar means such that. X such that. And then we look at what comes after it. What comes after it is x is greater than or equal to -2. So reading this, we would say x such that x is greater than or equal to -2. Now, practically, what do you care about? All you really care about is the inequality. That's it. The inequality is what matters. So we need to be able to graph that inequality. So obviously we're going to have -2. If we are greater than or equal to, so if there's an equal sign, we're going to have a closed circle. And then greater than that is everything bigger. So this graph in green conveys the same information as the set builder notation. It's two different notations, but the exact same information. And then we need to be able to put this in interval notation. Interval notation is always going to have two numbers or two symbols separated by a comma, and it is going to describe where your shading starts and where your shading ends. On our graph, the shading starts at -2, and then it keeps going. It doesn't have an end point. It goes on to infinity. And so our end, we say, is infinity. In order to convey that it's a closed circle, that gives us a bracket. Bracket is always a closed circle or included. Do we remember what it means if we're not included? Instead of a bracket, we use parentheses. Infinity is not a number. Infinity always gets a parenthesis. So infinity is not a number, always gets a parenthesis. Okay, in B, similar idea. This is red. X such that, so x such that, or a number such that number is between 0 and 3. Again, when you're going to graph it, all you care about is the inequality. That's it. The x such that, we don't care about that. So on our number line, we're going to have 0 and we're going to have 3. 0 is not included, so it gets an open circle. 3 is included, so it gets a closed circle. And then we shade everything in between. So again, this graph conveys the exact same information as the set builder notation, just looks different. Interval notation, where we start, where we end. We start at 0, go towards 3. 0 is not included, so it gets a parenthesis. 3 is included, so it gets a bracket. You don't need to write these lines. I do to tell me that I'm filling in information. You don't need to write them. So this all convey the same information. What I would like you to do is take a minute and try to do C, please. So take a minute, try to do C. How'd we do? Okay? Questions before we jump in a completely different direction and talk about order of operations? Okay, like I said, we're going to do order of operations, and I'll give you a short break. So, moving on. Order of operations. If you remember, the way to remember order of operations is PEMDAS. So I know you've done this before, but let's just write it out so we all know what we're doing. P stands for parentheses. E is exponents. M is multiplication. D is division. A is addition. And S is subtraction. Here's what is absolutely most important for you to remember. Multiplication and division are the same step. So you don't do all the multiplication, then all of the division. You do them together, whatever comes first. Similar idea with addition and subtraction. Same step. So you're not going to do all the addition and then all of the subtraction. You'll do them together, whatever comes first in the equation. Okay, so let's do our first example. Example A. Evaluate when x is 3, y is -2, and z is -1. We're going to start by plugging these numbers in. So I get 3 squared plus -1 squared over 3 add -2. Now, I purposely made a mistake in the way that I wrote this. Anybody know what that mistake is? -1 has to be in parentheses. We are squaring all of z. Z is -1. Here's why that matters. -1 squared, what that means is -1 times -1. If I write it instead like this, what does that mean?
-1 squared.
Right. It's a negative times 1 squared. So you would do 1 squared, then you're going to multiply by a negative. So these two are different. A lot of times students will mess themselves up because they write it wrong. Not because they do it wrong, but they write it wrong. Okay, so in this one, we have division, so we might think we need to do that first. In reality, what's happening when you have a fraction, do the whole numerator, whole denominator, then deal with the dividing. Okay, so in our numerator, we have some exponents. 3 squared is 9, -1 squared is 1. Okay, so then we can't do the division yet because, again, we said we need to simplify numerator and denominator first. In the numerator, we get 10. In the denominator, we get 1. 10 over 1 gives us 10. Okay, in part B, again, we're evaluating. This time the numbers are already plugged in for us. Order of operations wise, we have to do the parentheses first. When we are doing the parentheses, we have to follow order of operations. So, first thing, or next thing really, is exponents. So that's what we're going to do next. -2 cubed, so -2 times -2 times -2 is -8. 4 squared is 16. What I'm going to do is simplify the parentheses and then deal with the 7 plus 2. So I'm just going to handle the parentheses first. Okay, so now we said multiplication and division. We're going in order. So first thing that happens is that 3 times -28, which is -24. Then we have 16 divided by 8 is 2. So when we subtract them, it gives us -26. Remember, though, we still have the 7 plus 2 to deal with. Because multiplication and division have to come first before your addition and subtraction. A lot of students will do all of this right, and here's where they make the mistake. They'll add the 7 and the 2, then do the multiplying. What has to come first? Multiplying. Yeah, multiplying is going to have to come first. 2 times -26 is -52. When I add 7, it gives me -45. Last one before our break is C. In C, we're simplifying. Our answer is not going to be a number because it has x in it. So our answer will have x in it. Again, we have to deal with the parentheses first. I do not like subtracting, so I try not to subtract if I don't have to. What I would do, instead of that -3, is change it to adding a negative. So then we have kind of two things going on. We have this addition, and we have this -3 being multiplied. Instead of the addition, we're going to do the multiplication first. So I'm going to multiply this -3 in, so I get 5x plus -12x. And then be careful with your signs here. -3 and -1 will be +3. Then adding like terms, 5x and -12x is going to give us -7x plus 3. And then we have the 3 minus 4. So again, two things happening: subtraction, multiplication. Multiplication has to come first. As I said, I don't like to subtract, so I like to think of this as adding a negative. What I would do then is distribute a -4, which gives us 28x and a -12. And then lastly, combining like terms, we get 28x, subtract 9. Next thing we need to talk about that you've seen before is operations on polynomials. So we're going to take polynomials, add, subtract, multiply, divide them. If we're looking at example 3a, we notice that we are subtracting polynomials. We are going to approach subtraction the same way we did on the previous page. I prefer to distribute the negative. The parentheses don't really matter except to distribute the negative. So we end up with a -3r squared, a +5r, and a -7. That first polynomial doesn't really need the parentheses, so I don't need to write them. I forgot to mention, the directions say put it in standard form. Standard form means highest power goes first. So if we're combining like terms, r squared is our highest power. R squared subtract 3r squared is -2r squared. Not r to the fourth, doesn't change the exponent at all. -2r and +5r is going to give us +3r. And -5 and -7 gives us -12. That is our final answer. That is in standard form. We have highest power, then we decrease. Okay. In something like, we're going to skip B for a minute. We're going to go to C. We'll go back to B. In C, we are distributing. When you're multiplying, you can multiply the numbers outside the root and the numbers underneath the root. So 4 root 3 times x. 4 is outside the root, x is outside the root, so that gives us 4x, and the root comes along. Then 4 root 3 and 2 root 2. 4 and 2 are outside the root, so that gives us 8. 3 and 2 underneath the root, which gives us 6. So then the question is, can I combine those? No. If you're going to combine, numbers underneath the root would have to be the same. So we'd have to have a root 3 and a root 3. Also, the first term has an x. So that's our final answer. Okay. In D, can I distribute this square? Is that a legal move? No, why not? Because of the subtraction. If you have addition or subtraction in the parentheses, you cannot distribute the square. Instead, remember that a square is multiplying by itself. So this is really 2x minus 3 times 2x minus 3. You can FOIL, you can draw arcs in. If you've had me before, what you see that I normally do is I normally draw a box. You don't have to do this. This is my preference, though. So I have a 2x minus 3 and a 2x minus 3. 2x times 2x gives us 4x squared. 2x times -3 is -6x. 2x times -3 is -6x. And -3 times -3 is +9. And then last thing, we combine like terms. So we have negative 6x and negative 6x gives us negative 12x. Then we have that positive 9 and that 4x squared. And remember, standard form, highest power on down to lowest. Does that seem familiar? Yes, it should. Great. Take 3 minutes. Do B and E, please. Take 3 minutes, do B and E. Okay, so let's move on to the last topic, which is complex numbers. Here's what you need to know about complex numbers. A complex number has a real part and it has an imaginary part. So A is the real part. Any number that has an I with it is the imaginary part. What you need to know is that I is the square root of negative 1. If we square both sides then, what that tells us is that I squared is negative 1. So those are the two rules you need to know. I is the square root of negative 1 and I squared is negative 1. So in example 4, we're performing the two operations. In part A, we need to simplify the root. Here's what you should see. Right away, if there's a negative, that's going to give us an I. Because the square root of negative 18 is really the square root of negative 1 and the square root of 18. Well, the square root of negative 1 is I. Square root of 18 we have to break down. I might break down differently than you've seen in the past. What I do is I break down 18 as much as I can. So 18 is 9 times 2, and 9 is 3 times 3. Any pair of numbers comes outside the root. Anything that's left stays underneath the root. 3 is a pair, so it goes outside the root with the I. The 2 that's left goes underneath the root. So then we have 2 minus 3i root 2. We cannot simplify that anymore, so that's done. Again, in order to add or subtract, we would have to have the same number underneath the root, which we don't. Lastly, B, 3 add 2i, that whole quantity squared. Why am I not allowed to distribute the squared? Come on, I asked this before. Jamie? Addition. If you have addition or subtraction, you cannot distribute the squared. So instead, this is 3 plus 2i times 3 plus 2i. Again, you can FOIL, you can draw the arcs in, you can do a box, I don't care, whichever you prefer. So this is 3 plus 2i times 3 plus 2i. 3 and 3 is 9. 3 times 2i is 6i. 3 times 2i is 6i. 4i and 2i and 2i rather is 4i squared. So this gives us 9 plus 12i plus 4i squared. This is not done. You are allowed to leave your I in your answer because complex numbers have I. Complex numbers, though, do not have I squared. So the last thing you have to do, you are never allowed to leave I squared. I squared is negative 1. So this is really 9 plus 12i. And then here, 4 times negative 1 is negative 4. So this is 5 plus 12i. Technically, the real part should come first, then the I. Now, if you write 12i plus 5, I'm not going to count it as wrong. It's just not the correct notation. Okay, I know that was 4 pretty random topics that were thrown at you. So hopefully that was enough to dig it up from wherever it was in your memory. Any questions for me?